Okay, students, welcome to part 3 of the skeletal system lecture. In the first two parts, we learned about the structure and function of bone. We learned about the two different types of bone, compact and spongy bone. We learned about two processes that create bone, intramembranous and endochondral ossification, and we also learned about how bones repair themselves. So now what we're going to do is move on to factors that regulate bone growth. And what I want you to keep in mind is that there is always going to be variation. I'm giving you just kind of the generics here in healthy adults of younger age. Remember though that the factors that we're learning about now, they are going to vary based on genetics, age, sex, and lifestyle. So, remember, these are the generics, and I'll point out some variations as we go along. So one of the things that affects bone growth, as you might expect, are circulating hormones. And they have a direct effect on those bone cells that we learned about. So there's one that plays a major role called parathyroid hormone, secreted by the thyroid gland. And what it does is that it has an effect on osteoclast activity. And remember, osteoclasts are those cells that break down old bone. And when they break down old bone, remember they're kind of digesting the concrete. And that concrete, or the ground substance of bone, is calcium. So as parathyroid hormone increases, it causes osteoclast activity to increase, therefore increasing the availability of calcium in the blood. So when would this be necessary? Well, you've always got this gas pedal and brakes as far as the parathyroid hormone regulating the amount of calcium in the body. But there might be a situation where somebody's malnourished, not getting enough calcium in their diet. So in that case, parathyroid hormone might be elevated, but also in pregnant women, especially during throughout the whole pregnancy, but especially when fetal skeletal development. Calcitonin is the brake pedal. So if we think of parathyroid hormone as the gas that increases osteoclast activity, calcitonin is the brake pedal. Calcitonin does the opposite of parathyroid hormone. It decreases osteoclast activity and therefore decreases the amount of calcium in the blood. Growth hormone, thyroid hormone, both of those have an effect on osteoblast activity, so they increase osteoblast activity. And remember, osteoblasts are the cells that lay down osteoid, the ground substance, and the fibers. And growth hormone also increases osteoclast activity. Growth hormone and thyroid hormone do that. So remember, osteoclast activity is just as important as osteoblast activity when making bones. You lay down new bone, you break down old bone. Lay down new bone, break down old bone, and this is part of the process of growing the skeleton. As we reach puberty, estrogen and testosterone play a greater role in the activity of osteoblasts. So both of those increase osteoblast activity. So when individuals reach puberty, this is often when you see those growth spurts. And one of the things that happens here is that osteoblasts lay down bone or osteoid faster than the cartilage at the epiphyseal plate can lay down new cartilage. And so that causes the plate to seal up. I don't have that same picture as before, but if you're confused, go back to the very end of the skeletal system part 2 lecture, where I talk about the epiphyseal plate. Remember, that's the growth plate, also called the metaphysis. That's made of cartilage when an individual is growing. And it's a kind of a race between cartilage cells and bone cells to for the cartilage cells to lay down cartilage faster than bone can replace it, so that the bone actually lengthens. But in the presence of greater amounts of estrogen and testosterone, osteoblast activity is going to outpace chondroblast activity, and it's going to seal up those growth plates, and then growth in length can no longer occur. Bones can't get longer, you can't get taller. You're done growing once all that cartilage is filled in. Other factors regulating bone growth: ions, as you might expect, very important. Grandparents or moms and dads might tell you to drink milk. Why milk? Well, milk is loaded with calcium. There are other minerals as well that you find as components of the concrete or the ground substance of bone. Calcium's number one. I think that these are probably in order of abundance. So these are the top three: calcium, phosphate, magnesium. All of these you'll get from in decent quantities from a good balanced diet. Vitamins, of course, are important. Vitamin A stimulates osteoblast activity. Vitamin C is necessary for collagen production, and I'll show you an example of that here in a second. Vitamin D is necessary for calcium absorption. So you've got to have vitamin D in order for the calcium that you ingest to get into your bloodstream. So if you go to your fridge, look at your milk carton, and or go to a box of cereal in your house, and I am pretty sure that you'll find either on your milk carton or in your cereal that your cereal or the milk will be fortified or have added vitamin D in it. So this ensures that you're getting the calcium that naturally occurs in the milk, but you're also getting the vitamin D that helps you absorb that calcium. So just a little piece of information there. And then vitamin K and vitamin B12. So let's look at what happens as we age to our skeletal system. And both of these processes I'm sure you've heard of, and they both occur in men and women. However, in women, these conditions begin earlier and accelerate faster. So one of the things that happens as we age is we lose bone mass. Our bones become less dense, and that can lead to an increased risk of fracture. So the first condition is kind of like the precursor to the next. Now, let me tell you that not all people with osteopenia will get osteoporosis, but osteopenia is kind of like, it's not the same as osteoporosis. It's not the lead up to osteoporosis, but it's the process, or it's the condition where we start to lose bone mass, whereas osteoporosis is kind of the same thing, but it's much more complex than osteopenia. So osteopenia is a reduction in bone growth. So you're not doing your daily repair of bone growth, and or you have inadequate repair of bone. So you have a reduction in bone growth or inadequate bone growth. So you might be not making or replacing old bone as fast as you once were, and you get a loss of bone mass through what we call demineralization. That ground substance, the concrete of bone, starts to become a whole lot less dense. This occurs in women beginning in the 30s, and from then on you lose you have an 8% loss of bone mass every 10 years. And then that accelerates when you're around 45, and then by 45 you've lost 30, or accelerates at 45, and by the time you're 70 you'll have lost 30% of your bone mass. So at 70 your bones are 30% less dense than they were. What can help with this? Obviously a balanced diet full of the ions you'll need, vitamins you need, but also exercise is fantastic for this. I'm not going to say it's going to stop. Oh my gosh, I can't spell exercise today. Oops, there we go. having a balanced diet and making sure that you're taking or having a balanced diet and taking supplements if advised by your doctor might slow down bone loss, but you're still going to lose bone naturally. But exercise is really good for this. A little bit of weight-bearing exercise is good for this, because when you do that, you kind of, your body's telling the osteoblasts, hey, hold on here, stop getting lazy. Naturally, as we age, osteoblast activity decreases. Well, osteoblasts are the bone growers. But as we age, osteoclast activity stays the same. So we're breaking down bone at the same rate we were, but we're not building it back as fast. And so a little bit of physical exercise, weight-bearing exercise, will let these osteoblasts know, hey, you guys can't slow down. We still need you. And it will reduce the rate at which they slow down their production of osteoid. Osteopenia occurs in men too, but it doesn't start until about the age of 60. And then men will experience a 3% loss of bone mass every 10 years. So you can see how it affects women the greatest. Primary reason, like we had just discussed, estrogen plays a huge role in osteoblast activity. Remember, estrogen increases osteoblast activity. So if you are, let's see, that my graph isn't going to be very good, so excuse me. If this is kind of a graph of women's estrogen over their lifetime, this would be, at this point right here, would be somewhere around 40, where estrogen starts to dramatically dip, and that's what causes that bone loss. And while men do have estrogen, their bodies and their bones, their osteoblasts, are more so controlled by testosterone. And men's testosterone, pretty much throughout their life, not surprisingly, is pretty much a straight line as far as concentration goes. So that's why women are more susceptible to osteopenia. And then in some individuals, and it's mostly genetic, some individuals will develop a much more severe loss of bone mass called osteoporosis. And that's so much loss of bone mass that you have an increased chance of fracture. So you have so much loss of bone that it compromises the integrity and the strength of the bone. And so even minor injuries can cause fracture. Or in some cases, the bones can just collapse under the weight of your body. I'll show you a picture of this in a second. Another thing that happens to us all is a decreased rate of protein synthesis. And you might be thinking to yourself, well, what protein is that? What protein decreases? Collagen. Remember, collagen is like the rebar in your bone that's supporting and giving your bone flexibility. So we have a decreased rate of collagen production. So you have reduced flexibility, and that leads to a greater risk of fracture. Let's look at an example of a healthy bone versus an osteoporotic bone. So you're looking at the vertebrae, bones of the spine. Here's one vertebra that you see right here, right? And then the author is saying, okay, look over here. This is that vertebra from the inside. So the vertebra on top is normal, or non-osteoporotic. We'll just say normal, where it has the structure of an irregular bone, like we learned earlier on in the lecture. You've got a compact bone there, compact bone here, and then in the middle, just like your sandwich, you've got the spongy bone. And so that's what, under normal circumstances, that should be the structure, the composition of that bone. But if you look down at letter B, this is one of those vertebrae from the individual who has osteoporosis. And now what you can really clearly see is that the compact bone is much less dense. It looks more like spongy bone, right? And then the spongy bone on the inside is just kind of falling apart. So this spongy bone inside here is going to collapse, right? Kind of like floors of a building collapsing on one another. So these vertebrae here actually shrink. They get smaller. So this is one of the reasons that older people lose a couple of inches on their height as they age, because the spine right here is carrying the majority of your body weight. So over time, these vertebrae get compressed. They're not as tall. They get shorter and shorter. So think about grandma and grandpa or any of the elderly people that you know or you've known all your life. You've probably felt like, oh, you guys seem like you're shorter, but maybe it's just me because I'm getting taller. It's a little bit of both. You've probably gotten taller as you reached your 20s, and then grandma and grandpa, while you were reaching your 20s, they were getting shorter. So the difference is much magnified. Okay, at the beginning of the lecture, I mentioned or I stressed that there are going to be variations. There can be a number of different variations in individuals' skeletal systems based on lifestyle or age, but there are also gender or sex-related variations. And so if you just had a skeleton, if we were in class, I'd be able to show you this, but if we just had a skeleton, no soft tissue present, there are some indicators in the skeleton that can help you to identify whether the skeleton belongs to a male or a female. So men's skeletons are generally denser, heavier, and larger. And the reason for that is because men's muscles are larger on average, not all the time, but on average than women's. And so when you have larger muscles, they create denser, heavier, larger bones. The bumpiness, there's a term for this. I don't even know if that's a word, but rugosity means the bumpiness of the skeleton. And this means that what you'll learn in lab this week and in next week is that there are all kinds of bumps and grooves and spines and things on bones, but men tend to have more distinct bone markings, rougher bone markings than do females. If you look at females down here, their skeletons are said to be more gracile. Gracile means smooth. So that's a result of, generally, on average, women having smaller muscle. Remember, muscles attach to bone. And at the point of attachment, when those muscles pull on bone constantly, the stronger the muscle, the more pull they're going to have on the bones, and therefore the larger bump there is going to be on the bone from that constant pull. Or if you're female, the smaller the bump or the smaller marking that attachment will make. We see differences in the cranium as well, in the skull. So men tend to have a more distinct brow ridge. So you can feel along your eyebrows, you can feel that brow ridge right underneath your eyebrows. Men tend to have a more distinct brow ridge, and their forehead slants backwards, which is sort of the opposite as far as women go. They have less distinct brow ridges, and their forehead is, or the frontal bone is a little bit more rounded. And then lastly, probably the most obvious place you would expect to look for differences in the sexes of the sexes in the skeleton would be the pelvis. Female pelvis is going to be designed to allow for a fetus to pass through. Males, not so much. So a male pelvis is taller, and they have deeper os coxae, are the two hip bones, the names of the hip bones. So those hip bones are taller. And then there's something called a pubic angle that I think I have a picture of here in just a second. That pubic angle is less than 90 degrees, whereas in females, that pubic angle is greater than 90 degrees. And females have a wider pelvic inlet. And you'll learn about what the pelvic inlet is in lab, and there are also pictures in your textbook. But essentially what that is the space for which is available for the head and shoulders of a baby to pass through. I think there's a pelvic. Let me go back to some health-related variations in the skeleton. And I've said this a couple of times, that you might have a health-related condition that affects your skeleton, or your lifestyle might affect your skeleton. So let me give you 2 examples here. This individual right here is suffering from a condition called scurvy. Scurvy is a lack of vitamin C, and vitamin C is only obtained from your diet. More specifically, at least in the highest concentrations, in fresh fruits and vegetables, mostly fruits that are grown in the sun. And so what scurvy, or lack of vitamin C does, it reduces collagen production. And one of the things you see are bleeding gums, like this individual has down at the bottom. Right here, the gums are bleeding. But it also results in tooth loss. So this individual's missing a tooth. And that's because collagen fibers play a role in anchoring that tooth in the alveolar fossa, or the socket. So once you lose that collagen, your teeth are going to become weak in their sockets. You might know from earlier classes, but pirates, or people who spent long periods at sea would often suffer from scurvy. And the reason for that is the fresh fruits or fresh produce in general is going to rot. So that gets eaten first. And when you spend long periods of time at sea, what you have left, really, at least historically, were like things like salted meat, meat that's like soaked in like salt water, so it preserves it, so it lasts longer. Bread. I don't know if any of you guys are in the military, you might know this. There's a really, I don't even know what you call it. It's really, it lasts forever, type of bread called hardtack. And this is like a really dense, calorie-dense bread that almost never spoils. So those things don't have vitamin C in them. So people who were spending lots of time at sea often came ashore with scurvy, missing teeth, bleeding gums, and that was quickly remedied by just ingesting fresh produce. And then these individuals over here are suffering from rickets. And rickets is a lack of vitamin D. And vitamin D, remember, is necessary for calcium absorption. So lack of vitamin D might make the ground substance, the concrete, not as dense. And then what you see in these kids, in this age progression, it's not the same kid, they're just different ages of kids. You see that their legs begin to bow outwards. And that's because as they gain weight, there's more pressure put on their legs, more weight on their legs, especially this poor young lady right here. She's got a lot of pressure put on her legs, and that causes the legs to start to bow. And that's because they don't have as much ground substance, not as much concrete, but you still have the collagen. And remember, collagen is flexible. So the legs begin to flex, the bones begin to flex and bend under the weight of the individual. Other things, other health-related variations that are going to affect the skeleton, there's a condition called gout. And that happens, sometimes that's genetic in individuals. Some people are more genetically predisposed to suffer from gout. Some can give themselves gout by having a poor diet. But what gout is you get crystals of what we call uric acid building up in your joints. And those crystals cause physical damage to your joints and cause inflammation at your joints and can be really painful. Usually gout is caused by excess purines, a component found in some types of meats, not all, some types of fish, and unfortunately in high quantities of beer. If we live long enough, we're all going to get arthritis. Some of us are going to get arthritis younger, some older, some of us are going to get mild arthritis, moderate, and some might get severe arthritis. Anything that's an itis is an inflammation. And ARTH, this prefix that you see right here, means joint. So this arthritis literally means inflamed joints. So this will happen just as a natural result of aging. Your joints become inflamed. but also there's a condition, and it affects more women than men. This is an autoimmune condition. It's called rheumatoid arthritis, where the immune system attacks an individual's joints. So that's a type of arthritis. And then there's just regular old osteoarthritis that occurs when, as we age, the cartilage that would normally pad our bones so that they don't rub together as we walk, the cartilage starts to break down, and then you get bone on bone grinding. Like, think of your knee, your thigh bone rubbing against your lower leg bone as you walk, because your cartilage has gradually been reduced, the amount of cartilage. So this will happen as we age naturally. But also, if you've been an athlete as a younger individual, or had some damage to your cartilage, that may cause you then to have arthritis in those certain locations a little bit earlier than you naturally would. So we've gone over health-related variations, variations amongst the different sexes, and we've looked at the vitamins, minerals, and hormones, and the roles that those things play in the skeletal system, what role all of these things have on your bones. So if you think back to the beginning of the lecture, prior to learning anything about skeletal system, anything about bones, you're probably like, oh yeah, they're hard, they're white, they're, non-living. And we've learned that they're obviously living tissue, hard connective tissue, and there's so much that goes into creating a skeleton. So many factors, so many things that can be affected, or so many things that can affect bone growth. And so, bones at first glance perhaps might seem really boring. You don't really learn that much information about them, or you may not know much information about the individual just by looking at their bones. But in fact, you can learn a whole lot of information about somebody just by looking at their bones. You can learn their age, their gender. You could learn a little bit about perhaps maybe if they've had a fracture sometime in their life. You may see that evidence of arthritis, a number of different things. So skeletal system and the tissue that makes up the skeletal system is actually pretty cool, fascinating. And if I had more time, I would talk even more about it. It's pretty neat. But I'm going to let you go. This is the end of part 3. This concludes the chapter 5 lecture. There will be no more parts after this. Okay, take care. On this picture, yeah. So this would be a female pelvis. Just so happens to be a female pelvis. This is the pubic angle. So this is greater than 90 degrees. So that would be a female pelvis. This is an os coxa, this bone right here. And in females, that's going to be shallower. Whereas if this were a male, those os coxae would be maybe a little bit taller. And then also this distance right here is going to be a little bit wider in females. You might call this hip distance. And that's to accommodate the shoulders and head of a fetus passing through here. That spot right there is called the pelvic inlet. So that's larger in females and smaller in males. Oh, one last thing. At the end of this, recording, at the end of the PowerPoint, there are a couple of photos that are taken from your textbook that are about bones, bone markings, and then which bones make up the axial skeleton and the appendicular skeleton. I made a separate recording on these slides, and it's in Canvas, and it's the recording that you'll use to help you get started on the lab activities. So that's why I'm not going to finish lecturing on these, because there's a totally separate lecture that kind of explains these. It's either entitled like the Getting Started for Skeletal System Lab Activities, or it might just say watch this to help you get started on the skeletal system, something like that. So that's why I'm not lecturing or recording the lecture right here. Totally separate one available for that. Okay.